What if a comet's tail pointed the wrong way? On October 25, 2025, interstellar object 3I Atlas was confirmed to have a tail aimed directly at the Sun. This physics-defying anomaly triggered quiet, urgent protocols from global space agencies, now tracking a visitor that breaks all known rules of our solar system. What is this mysterious object, and what strange forces are guiding its impossible journey? Let's delve into it. The impossible tail. Here's where the story breaks the rules of science. Every comet ever observed has two tails, both pushed away from the Sun by its immense power. A bluish ion tail, made of charged gas, is pushed straight back by the solar wind. A brighter, curved dust tail is pushed more gently, by the pressure of sunlight itself. The German astrophysicist Ludwig Biermann first theorized the solar wind in the 1950s, precisely because comet tails always act as celestial weather vanes, pointing away from our star. Yet, high-resolution images of 3I Atlas from the Gemini South Observatory in Chile showed a narrow stream of material stretching toward our star, directly into the solar wind. This wasn't just strange, it was physically impossible, as if it was powered by a force strong enough to overcome the Sun's constant outflow. Astronomers immediately scrambled to verify the data, but multiple observatories confirmed the impossible tail was real. This meant our understanding of cometary physics, a field we thought was settled, was suddenly on shaky ground.
Emergency protocols.
When an object in space defies known physics, it's not just a scientific curiosity, it becomes a global priority. Almost instantly, 3I Atlas was flagged for reprioritization across major space agencies. Internal anomaly detection systems on the James Webb Space Telescope sent directives to switch its observational focus, a process that normally requires weeks of peer-reviewed proposals. The Hubble Space Telescope began tracking it more aggressively. This triggered internal protocols at NASA and observation drills within the European Space Agency's Planetary Defense Office. NASA's Planetary Defense Officer, Lindley Johnson, leads a team whose entire job is to prepare for celestial threats. While 3I Atlas posed no impact risk, its deeply abnormal behavior required the same level of scrutiny because any object that doesn't follow predictable physics is an unknown variable. It became a high-interest non-local object, and the world's most powerful eyes were quietly retasked to watch its every move, with data streams being shared across international lines, with an urgency typically reserved for imminent threats.
The sunward plume.
So, what were the telescopes actually seeing? Was it a tail, or something else? Astronomers quickly began analyzing the feature, trying to determine if it was a true tail, or a different phenomenon known as a cometary jet. Comets sometimes shoot out narrow geysers of gas and dust, when a sunlit patch of ice cracks and sublimates, a process studied in detail by Nicholas Thomas, a leading expert on cometary activity with missions like Rosetta. But the plume from 3I Atlas was completely different. Normal jets are erratic, short-lived puffs of vapor. This plume was a perfectly stable, tightly focused column that lasted for hours, maybe even longer, as if it were being projected from an engineered nozzle. It was a sustained, forward-facing jet, blasting directly toward the Sun, requiring an immense and continuous internal energy source to maintain its structure against the solar wind. To make things even stranger, a faint ghost-like countertail was still visible behind the comet, behaving normally. The question was no longer about the tail following the comet, but the powerful, impossible plume that was leading it.
Chemical anomaly.
Just before the impossible tail made headlines, the James Webb Space Telescope delivered a chemical analysis that deepened the mystery. Its infrared spectrometer found a staggering 8-to-1 ratio of carbon dioxide to water vapor being vented from the object. To put that in perspective, this is an unheard-of ratio for comets in our solar system, which are typically water-dominant because they formed past the frost line where water ice is abundant. Even the last interstellar visitor, 2I Borisov, wasn't this extreme. This finding, championed by NASA scientists like Stephanie Milam, sent shockwaves through the astronomical community. CO2 sublimates at much colder temperatures and far more explosively than water ice, which could explain the powerful plume, but it implies the object formed in a star system profoundly different from our own, perhaps a carbon-rich environment where water was scarce. Or more speculatively, it could be the frozen exhaust from an ancient, long-dead technology. This chemistry is so alien it forces us to reconsider the building blocks of planetary systems elsewhere in the galaxy.
Nickel without iron.
If the bizarre chemistry wasn't enough, the next piece of data broke one of the oldest rules in planetary science. Spectral data from the Keck Observatory in Hawaii revealed the clear signature of vaporized nickel in the comet's coma, but its elemental partner, iron, was completely missing. In every asteroid, comet, or meteorite we've ever studied, nickel and iron appear together, forged in the same stellar furnaces and planetary cores. Their cosmic ratio is a known standard. As planetary scientist Denton S. Ebel can confirm, finding one without the other in nature is like finding smoke without a fire. Their association is that fundamental to cosmochemistry. Astronomers rechecked their instruments, but the results held. The leading theory is the presence of nickel-carbonyl compounds, exotic molecules used on Earth in industrial processes to purify nickel by separating it from iron. While they could theoretically form in deep space, their presence on this object is another deeply uncomfortable coincidence, blurring the line between a natural anomaly and an artificial one.
Silent escalation.
This string of anomalies triggered a quiet but significant shift in the global observation network. This isn't about panic, but about priority. The International Asteroid Warning Network began running trajectory drills using 3I Atlas as the simulated object, highly unusual for a non-impacting body. NASA's SphereX mission, designed for infrared sky mapping, had a portion of its bandwidth redirected. Even the Swift telescope, which usually hunts for high-energy gamma-ray bursts, was nudged to observe the object. Detlef Koshny of the European Space Agency has noted that this kind of cross-agency retasking is reserved for high-priority events because telescope time is a fiercely competitive resource. Diverting an asset, like Swift, means other important supernova or black hole research gets put on hold. Observers reported quiet inquiries about sharing targeting schedules, a practice normally used for fast-moving objects or potential impact threats. No one was smashing a red button, but the silent escalation was clear. The world's space agencies were treating 3I Atlas as a profound enigma that demanded immediate answers.
Trajectory deviation.
As 3I Atlas neared the Sun, another puzzle emerged from its trajectory. The object wasn't moving in a way that could be explained by gravity alone. It was experiencing non-gravitational acceleration. This phenomenon is real. Comets can be gently nudged by the force of outgassing. But, the deviation in this object's path didn't align with the expected forces from a typical comet. In fact, it seemed to be influenced by the impossible sunward plume, acting almost like a thruster. This was eerily reminiscent of 1I Oumuamua, the first interstellar visitor from 2017, whose own unexplained acceleration led Harvard astronomer Avi Loeb to speculate it could be an alien light sail. Unlike Oumuamua, 3I Atlas was visibly outgassing. Yet, the math still didn't quite add up. Orbital analysts noticed the changes weren't smooth. They came in brief, measurable jumps, more like a series of course corrections than a steady push. When an object from another star system starts moving in ways we can't fully model, it stops being just a rock.
The AI flag.
Perhaps the strangest detail came not from a human, but from an algorithm. Publicly accessible logs showed that weeks before the tail anomaly was widely known, the James Webb Space Telescope had flagged 3I Atlas for manual review. It wasn't a command from an astronomer, but a trigger from its own automated AI system. This AI, similar to models like Morpheus developed by astrophysicist Brant Robertson, is trained on tens of thousands of known objects to recognize what's normal. It flagged 3I Atlas because its light curve, the pattern of its brightness as it rotates, didn't match a typical tumbling comet. A natural object usually has a chaotic, uneven surface, producing a messy light curve. This object's curve was too rhythmic, too clean. Some suggested it could be due to smooth, flat surfaces reflecting light in a predictable way. The fact that an AI built to ignore noise and find true anomalies essentially raised its hand and said this doesn't fit anything I know is incredibly rare. It suggests the object has physical properties fundamentally different from any natural body in its training data.
Ancient omens.
For millennia, humans have looked to the skies for meaning. When something broke the celestial rules, it was never ignored. Babylonian astronomers recorded tailed stars as omens of war. The Great Comet of 1680 terrified Europe and was so bright it was visible in daytime, spurring Isaac Newton to develop his universal laws of gravitation to explain its orbit. The famous Bayeux Tapestry depicts Halley's Comet in 1066, seen as a terrible omen before a historic battle. This deep human instinct to pay attention when the sky changes is resurfacing now. As noted by astronomy historian E.C. Krupp, this reaction is a modern version of an ancient tension. Online forums are exploding with theories and analyses. When the universe presents a puzzle that breaks the rules, we just can't help but wonder if it's a messenger. The question is, what is it trying to tell us?
The facts.
So, let's ground ourselves in what we know for certain. 3I Atlas was officially discovered on July 1, 2025, by the Atlas Survey in Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, a robotic survey designed to spot dangerous near-Earth objects, making its discovery of an interstellar one an ironic twist. It's the third confirmed interstellar object, following 1I Oumuamua in 2017 and 2I Borisov in 2019. It is estimated to be between 5 and 11 kilometers across, making it a true celestial giant, far more massive and complex than the tiny cigar-shaped Oumuamua. Its closest approach to Earth is calculated for October 29, 2025, at a safe distance of 0.36 astronomical units, posing no impact threat. The world's most powerful observatories have all studied it in one of the most intense, coordinated campaigns in modern astronomy. Every piece of data is being scrutinized, not just to understand this one object, but to learn about the chemistry and physics of a star system we've never seen. So, here we stand, with a cosmic mystery that challenges our most basic assumptions. We have a tail pointing toward the sun, a chemical signature unlike anything seen before, and a trajectory that doesn't quite follow the rules of gravity. The world's most advanced observatories and even their AI systems have all flagged this object as something extraordinary. Is it a natural relic from a star system profoundly different from our own, a place where the rules of planet formation are alien to us? Or is it something else entirely? As it makes its closest approach, we are on the verge of answers that could redefine our place in the universe. This story is far from over, and the biggest revelations may be yet to come. To stay updated on this incredible cosmic puzzle, don't forget to like, subscribe, and hit the bell icon. Thanks for watching Future Facts.